Yeah. So we're going to be kicking off now, like I said, and today's section is going to be like super technical. It's mostly focused on the contract aspect. So we're going to be learning how to basically use what's it called, the tokenbound accounts within our contracts, right? To set up tools within our contracts. Going to be learning how to use the registry, how to extend the component contracts to add new features and a whole lot of other things. Yeah, so before I proceed, I'm going to just share my screen. So if you know anybody who's supposed to be on the call who's not here, please just send them a ping, remind them that okay, we're already kicking off, and this section is going to be awesome. So all right, so let me share my screen in a minute. Oh, okay. Sorry. No, sorry, give me a minute. I don't know, I'm having issues sharing from me. I'll try again. Yeah, can you see my screen now?
Yes, we
Yes,
can
sir.
see it.
Oh, okay. Oh, that works now. Let me just expand this. Mm. Yeah, so this is like the Tokenbound account repository. So this basically contains like the core contracts. And I'm not going to be doing any sort of introduction because I believe we went through that on Monday and on Tuesday. So what I want us to do is we're going to walk through like the contracts and I'm just going to explain a few things before we look into what we need to do today. So if you go into the core contracts, there are like two major, should I say, contracts here. We have like the registry contract and we have the accounts contracts. So the registry contract is basically like responsible for deploying new token bound accounts. So think of the canonical registry like e-factory contracts, right? E-factory for token bound accounts. So it's responsible for deploying these token bound accounts and basically tracking them. And the registry function contains like three important functions. We have the create account function, which is this. Do I need to zoom in my screen or can you see this?
Yes, you need to zoom in a little bit, sir.
This good. This works, right?
One more.
One more, okay. How about now?
It's visible for me now. I don't know about others.
It's as if the screen is not getting zoomed.
Sorry, I didn't get that. All right, so
Zoom in if you can.
I think I'm like in 150 right now. All right, so I'm sure everybody should be able to see this now. This should be very visible. Correct.
Yes, visible very, yeah, it's not visible now.
All right.
disadvantage or is it for
All right, so let's proceed. Yeah. So, we have like three major functions here. We're not going to look into the logic or what they do. If you're interested in that, you could probably like go to the reports, check it out later. So we have the create account function, which is responsible for deploying a new tokenbound account. So as you can see, it takes in the implementation hash, it takes in the token contract, it takes in the ID and the salt, and basically deploys that particular tokenbound account and returns the contract address. Then we have the get account function, which is responsible for calculating the account address for an existing tokenbound account. So basically, you pass in the implementation hash, the token contract, the token ID, and the salt, and it also returns like the contract address of the tokenbound account. Then finally, we have this total deployed account, which is meant to like track the number
Yeah.
of deployed accounts for a particular NFT in a registry. Does someone say something? Is the size of the screen disturbing? Should I like should I just use my laptop instead?
No, it's fine also.
Oh, yeah, because I think Koshiyuki was complaining in the chat. Yeah, so what was I saying? Yeah, so and we have the total deployed accounts, right, which is responsible for tracking the number of deployed accounts for a particular NFT. So basically, you pass in the token contract and the token ID, and it returns like the number of deployed accounts for that particular contract. And we're going to be using the registry to like in the contract we're going to be building, right? We're going to be using the registry to deploy tokenbound accounts. Now, one question that have come up over and over and over again, right, is if like you can build your own registry. Now, while of course you can always like work on your own registry, right? It's usually important that the ecosystem has a single canonical registry. So a single place basically like people can go to like track all the tokenbound accounts, let's say deployed on the Starknet ecosystem, for example. So if you check all that chains, they have like a canonical tokenbound accounts registry that's deployed on like Ethereum base, Optimism, and so on and so forth. Then the second set of contracts, which is important and we're going to be looking at, is the account contract. Now, we built the account contract as components. So on Starknet, we have what we call components, which are like think of them as Lego building blocks. So right before the introduction of components, the issue of inheritance was a problem. It was a problem deciding basically like inheriting like probably should I say a particular code base that's probably been built by others right into your own contracts without having to like replicate everything they've done. And that issue was solved with Carry 1.0 with the introduction of components, right? So with components, you have a contract. A component, for those who are new to Carry, right? They are simply contracts, but they cannot be deployed, right? They cannot be deployed. They essentially cannot hold state. So, but just like a contract, they have like a storage, they have events, they even have external and view functions, right? As you can see, they look a lot like a normal contract, but the difference is you don't pass in rather than passing the should I say the contract state, pass around the contract states, you pass around what we call the component states, which is generic over like the contract states. So you could check out the Cairo book if you want to learn more about components. Now, the reason why we had to build the account the reference account right as a component is so that anybody could basically like pick this account component and basically extend it to fit their use case. And I don't think at the moment it's possible to directly rewrite like rewrite the functions contained within a component, although I think there's a workaround. You would probably confirm that later. But like basically the idea of components is basically you can take this account component and add new functions to it. For example, it was built to be very minimalistic, but you can basically add as much functions as you need for like your particular use case. So that's it basically. And as you can see, it contains some, I think it's just better to go through the interface because the code is quite like a lot and easily get confusing. So let's just check out the interface. So the interface basically, as you can see, it contains these functions. The is valid signature, the is valid signer. So is valid signature checks if like the signature is valid, that it's coming from the parent account. Is valid signer checks that the person trying to like execute this transaction through the Tokenbound accounts, like is the legitimate owner, right? Then you have the validate, which is responsible for validating transactions, the validates declare, the validates deploy, the execute, which are all methods we know from like a should I say a standard account contract on Starknet, right? This basically all this was done to ensure that this also like is compatible with I think SNP 5, that's the account SNP. And we now have some extra functions which are important. We have the token function, which basically returns the NFT that owns this Tokenbound account, right? The NFT which this Tokenbound account is tied to. Then we have the owner, which returns the account which owns that NFT that owns the Tokenbound account. Then we have the lock and its locked function. Now, if you're in the class on Monday, Jaden talked about the marketplace fraud issue, right? So we implemented this on Starknet, right, to curb the marketplace fraud issue. But we're going to be updating this, right, with the next set of contracts, which is probably going to be V3. We're going to be updating it to a more minimalistic implementation. So but the way we would try to combat this currently is using the lock and it's locked. So the lock function is responsible for like should I say locking an account. So let's say for example, I'm trying to sell let's see which participants are on the call. So let's say I'm trying to sell what's it called? My Tokenbound account to Kakuza, right? Now on Kakuza comes on or whatever marketplace, pyramid, elements, whatever it is, right? To like bid for my Tokenbound account. Now marketplace fraud is something like okay, while Kakuza pays for like let's say that my Tokenbound account had like 10 Ethereum, right? And because and then I decide I want to sell my Tokenbound account for 11 Ethereum. The value of my Tokenbound account is 11 Ethereum, right? Because of the 10 Ethereum contained in it. Now, imagine if Kakuza already pays for my Tokenbound account and then I send out the please, if you're coming into the call, try to mute your mic. I don't want to have to do that myself. So let's say oh, what was I saying? Yeah. So let's say Kakuza tries to pay for my Tokenbound account, right? And what's it called? And I transfer that 10 Ethereum after he has paid, right? It means that I've cheated him because basically he's paying 11 Ethereum, thinking that the 10 Ethereum, that's that particular asset is contained within the Tokenbound account. So the way we try to solve this, right, is when an account is listed on the marketplace, right, the account is locked, and during the whole process of the transaction, right, the buyer needs to check that okay, this account actually remains locked, so that he knows that okay, this is like what I'm paying for is what I'm going to be receiving. And during the period when the account is locked, the owner of the Tokenbound account can basically not execute any call through the Tokenbound account. Then finally, you have the support interface, which checks that okay, your account basically subscribes to the Tokenbound account interface. As you can see, there's the interface ID, which is very important. And yeah, that's just it. So every other thing you probably see in the repositories are just for tests, the preset contracts. We also have these upgradable components when anybody wants to probably also extend those components to make the account upgradable. You can actually check out that. Besides that, that's just it. So it's a very actually minimalistic, simple implementation. We're going to be making some new updates with like the feature of the contract, but that's about it. All right. So like I said, this is going to be a bit technical, right? So we're going to be this is the boilerplate for the contracts. It's a simple boilerplate. So what I want you to do is just head over to this link and a minute. Let me paste this in the chat. Yeah, so head over to the link, clone the repository, and when you're good to go, just let me know and we'll proceed. Are you guys still with me? Can you just head over on the repository, and if you're done, you can just give me a thumbs up so we can proceed. Mhm. Are we cloning, or most of us don't intend to follow the follow it like the live coding session? I'll probably go back to watch the tutorial later.
We are cloning.
All right. All right, so I think we can proceed now. I have gotten like a few dawns, so let's proceed. I'm going to stop sharing and just to share my VS Code right now. So, all right, so you can see my code editor, right?
Yes, sir.
Okay, minute. Yeah. Mm. Yeah, and the font size is it okay, or should I zoom in a bit
One
more?
more.
More. Okay.
Perfect.
All right. Yeah. So a brief description of what we're about to build, right? So it's a very simple contract, and the idea is like it's a factory contract that where people can deploy Tokenbound accounts from, right? So I know it's a bit redundant considering the registry itself is like already a factory contract, but just like shows how we can probably use it within our contract. So we have the factory contract. So this is responsible for like basically deploying like a Tokenbound account. Then we have the modified account, which is basically responsible for which is going to be where we're going to extend the account components, right? So I had to just do some of this beforehand so we can finish on time rather than battling with setups, especially considering today's the last session, and I want to ensure that by the end of the session we'll be able to like take any questions at all you've had from like all the previous classes, or as regards to what you're building, we can just take those questions before we go. All right. So we have about an hour, 4 minutes. Let's try to maximize that. So let's do a walkthrough through this, right? So this is the factory.cairo contract. And to understand what's going on here, let's start with the scap.toml file. So everything here you see here is like the normal conventional SCAP setting. So you have the package name, the package version, the package edition, the dependencies. Now, as you can see, within the dependencies, right, we inherit the Tokenbound accounts as a dependency. So we inherit the Tokenbound account as a dependency, specifying the Git repository and the particular tag we're looking to inherit. So if you go back to the Tokenbound account core contract, you can see that basically this is the link to that. I know it's called Starknet Africa because that was like the previous name we used to use, but if you use the current link, that's Horus Labs, so it would still like it should still compile, it should still work. Then the tag basically, which is like the tag for our contracts, the version of our contracts we want to use is 0.3.0. And now if you head into the factory contract, we have this interface which is specified, which specifies like the property of like the contract we're about to build. And as you can see, it just has the same thing as what the registry has, right? We have the create account function, which is responsible for creating like for deploying our Tokenbound account. And this function takes in the NFT contract address, the NFT you want to deploy this Tokenbound account for. It takes in the NFT token ID, which is the ID of like the NFT you want to deploy this account for. We take in the implementation hash, which is basically the class hash of like which is going to be the class hash of our modified account contract, right? It's going to be the class hash of our modified account contract. Then finally, we take in the salt, which is basically used to randomize your deployment. So I don't know if we mentioned this previously, right? But like a single NFT can have up to 1 million Tokenbound accounts. You can have as many Tokenbound accounts as you please, right? And the way that's made possible, right, is through the salt. So the salt basically is what randomizes the accounts deployments. So basically makes it dynamic, right? Gives you new contract addresses. So you can deploy more Tokenbound accounts so you're contracting as much as you change the salt. Then you have the get account function, which is basically responsible for retrieving like the Tokenbound account, right? So the NFT contract address, the token ID, the implementation hash, and the salt. It basically takes in the same thing, and it calculates the contract address and it returns it. Now in here, which is we have like a simple Starknet contract. It's a simple Starknet contract, right? And we named the module to be a factory. And so we are using, so this is basically we're trying to use the registry dispatcher. Now if you head into the interfaces, right, like interfaces folder, right, you can see that we have this iRegistry interface, right, and it specifies the interface of our registry function. So our registry contract. So this is the interface of the registry contract. And as always, like I said, it contains the create accounts, the get accounts, and the total deployed accounts. So we are going to be interacting with the registry contract, the deployed registry contract using this particular interface. And this is possible thanks to dispatchers, right? So where's that factory carrier? So dispatchers are basically the way we interact with Starknet's deployed Starknet contracts. We have the registry dispatcher, the traits, and the library dispatcher. And now the difference between we're going to be understanding, but if you're new to Cairo, difference in this, right? This and this, right, is that this is usually used to interact with a deployed contract which has states, right? And this is used to interact with a class hash that's usually stateless. So we're going to be using this, and I'm going to be explaining why we need to use that later. All right, so we have a simple storage struct and in our factory contract, and this basically tracks the number of deployed accounts that's been deployed through this particular factory. So it means now create account function every single time we what's it called, we create or deploy a new account, we're going to increase the number of the total deployed. That's this storage variable. And just one thing, right? So if you have any questions, as you can see, I am both the moderator and the speaker. So if you have any questions, I'll need you to like what's it called, to signify by unmuting your mic and speaking. Just unmute your mic and call my attention to your question. I'll check the chat from time to time also. You can also leave your question in the chat. So, okay, so we have the registry class hash. Now, the registry class hash is like basically the class hash of the registry contract. I forgot to mention you can find these details within the Tokenbound account repo. Let me get the link and I'll just paste that through and start sharing the screen again in minutes. Okay, addresses. Yep. So I'm going to paste this link in the chat, which contains, that's where we track all the addresses as regards like the contracts. Yeah. Yeah, so in there we track all the addresses. You can always find that there, the class hash, the contract addresses of both the registry for every single version we work on. All right, so back to what we're doing, right? So we have the registry class hash, which is this. Then inside here, we're going to write our implementation. Inside here, we're going to write our implementation. So we're just going to get started. So the first function we're going to be working on is the create account function. So we're going to say function create accounts. I don't like the fact that this does not have that formatting. I'm supposed to probably going to need to kill my VS Code and restart it again. But let's just build. So we have the create account function. And the first thing we're going to be passing in, right, is the contract state. As always, this is how we specify is an external function. Then checking it, we need the NFT contract address, the token ID, the implementation hash, and the salt. So it's going to need the NFT contract address, which is like a contract address. Someone's mic is unmuted. Okay. All right. So the NFT contract address, we're going to need the NFT token ID. The NFT token ID, which is going to be in 256. We're going to need the implementation hash, which is going to be felt 252, I think. And finally, we're going to need all the salt, right? We're going to need the salt, which is also going to be felt 252. All right, so this is going to return, let's just say this will return the contract address of the deployed function. All right, and the first thing we're going to do basically, right, is in what we're going to do is basically want to deploy this particular what's it called, Tokenbound account now. Now, I said earlier that we're going to use we're going to use this library dispatcher. And the reason we're going to use this library dispatcher is like kind of like found in the contract. So let's just go back to the contract and I'm going to let me explain something. All right, so I'll stop sharing that screen and I'll share this one again. Oh, where are thou? Yeah. All right. Can you confirm you can see my browser?
Yes, we can see your browser.
Yeah. All right. So within the registry contract, if you check the create account function, you would notice something. You notice that we try to get the owner of the NFT and we check that the person trying to basically call the function, right, is the owner of the NFT. Else we're going to throw an error. Now, things can get a bit tricky when you're working within contracts, right? Because if you try to let's just go back to our VS Code. Sorry for all the friction between it. VS Code, yeah. All right, so if you try to use this dispatcher, right, we're going to have an issue because when you use the dispatcher, it's more or less like you're trying to call the contract, which is trying to like call the create account function of the registry. So the caller will register as this contract instead. So the caller will be this contract rather than you yourself. That's the reason why we interact with the library dispatcher, so that it retains like the original caller, which is you. So what we're simply going to do is we're going to use the library dispatcher. Let's that's iregistry library dispatcher. And we're going to pass in the library dispatcher takes in a class hash. And that's the reason why we needed this registry class hash. So I'm just going to but we need to convert this to the class hash type. So I'm just going to do this. All right, so we get the class hash, we pass in the class hash, and we're going to call the create account method. Now this create account method is going to, let me just do this for meta. So the create account method is going to take in let's see. So you check the registry interface. The create account method takes in the implementation hash, then the token contracts, then the token ID and the salt. So we need to pass in the implementation hash. The implementation hash. We need to pass in the contract address, NFT contract address. We need to pass in the NFT token ID. And finally, we're going to pass in the salt. All right. So this is going to return, this is basically going to return what's it called? The what's it called? The contract address that's deployed, right? So if you check, the create account returns the contract address that's of the deployed, that's it of the deployed Tokenbound accounts. So let's just store that somewhere. Let's call that that's in here. So let's call that profile account address. All right. So once we get that, we also want to remember update the number of deployed accounts. So we're just going to say let's say all the total deployed. Then we're going to write to it. So what we're going to write basically is we want to first of all get the existing total deployed accounts, right? So we're going to get that and we're going to increase it by 1. All right. So once we do that, the last thing we're going to do is we're just going to return the account address. All right. So that in itself is just like a very simple implementation of a factory contract that's basically like, should I say, deploys a Tokenbound account. So as you can see, we interact with the registry, the deployed registry contracts, right? Using like the library dispatcher, and we call the create accounts method on it basically. Now the second function we need to implement basically is the get accounts. So let's just do that. So we have the get account function, and this takes in a snapshot, right? To the contract state, and it should take in the same thing, the NFT contract address. I can see some charts. Let me see their questions. Do you use the dispatcher if the contract was already deployed? Yeah, this contract is already deployed, right? And I explained we could use the registry dispatcher, which is really like the normal stuff we'd use to interact with, like the deployed contract. But now I'll explaining that if you do that, right, you're going to be interacting with the, should I say, with the deployed factory contract, which is going to be interacting with the deployed registry contract. So the factory contract is going to appear as the caller on the the registry contracts, right? And that's the reason why we do not want to do that. It's just similar to the problem we have with like delegate call on Ethereum, right? And so that's the reason why we want to use the library dispatcher instead, because when you use the library dispatcher, you're basically interacting with the class hash, and the class hash is stateless, and thus in that way you'd be preserving you'll be preserving the original caller in this case, which is like the person calling the create account method on the factory contract. I don't know if that makes sense, Kakuza, or should I throw more light? So Yusuf asked, how did you get the registry class hash? That's what I just shared now. So most of all these things have already been deployed beforehand. Like if you check the core contracts of the Tokenbound accounts, right? I don't know if I posted that here. The addresses.txt file. Yeah, I posted that. So within the addresses.txt file, you'll see a link to every single contract. Like we have two versions currently, the V1, which was the initial version released, and the V2. So the V1, you can see, you would basically see the contract addresses and the class hash. And the V2, you see the contract addresses and the class hash. So we're currently using, what's it called? We're currently using like the class hash of like the deployed V2 contracts. So you can just confirm. All right. Okay, so let's just proceed because of time. Yeah, so we're going to take in the NFT contract address, which is going to be a contract address. And we're going to take in the NFT token ID, which is a unit 256. And we're going to take in the implementation hash, right? Let me confirm the implementation hash on the salt. An implementation hash, which will be a field 252. And finally, we're going to take in the salt, which is also going to be a field 252. All right. So now this is going to return a contract address, right? This is going to return a contract address. And we're going to do the same thing, something similar, right? So we're going to interact with the library dispatcher, and we're going to be passing in the class hash, which in this case is the registry class hash, but we're going to convert it to like the class hash type. So we just basically use the try into dot unwrap method for that. The try into method basically, which the compiler will do the rest of the work. All right, so that's just all you need to do, right? So the once you do that, you have to call the get account method, and you're going to pass in the implementation hash, pass in the NFT contract address, just the same thing, right? The NFT token ID and the salt. All right, and we're just not going to add the semicolon at the end, right? Which, of course, if you're familiar with carry, you know that once we do not do that, it means that this is going to automatically return whatever value it gets, right? So we're just going to leave it that way. And yeah, so that's just like a simple, as you can see, very simple implementation of a factory contract, right, that interacts with the registry contract. Now the reason I wanted to show us this, right, is during your building, like during whatever you're building, right, you probably want to like interact with the canonical registry to deploy a Tokenbound account. So this is just like a demonstration of how you can interact with like with the registry. And yeah, so if you have any questions, you can just ask. So let me just try to compile this and a minute. Mm. Yeah, so let me try to compile this. All right, so we're running into a lot of errors. Let's see what's happening. Oh, okay. So some of these errors, apart from this, are coming from the factory contracts, but this is coming from the modified. So let's just start with commenting this out first. I'm probably going to work on it later so it doesn't throw error. Oh, a simpler way is just taking it out of the lib.cairo. It's all right. So we're running into errors. Let's try to fix this before we proceed. So yeah, that didn't know. That was a mistake, sorry. Then what else? What else? What else? I think that might be our only error. So yeah, so that's just the only issue we had. All right, so I don't know if you have any questions as regards this before we move into like the modified account contracts. If you have any questions, just ask and we'll basically look into it. Any question, guys? All right, so it seems like there are no questions. So let me confirm. Yeah, so no questions in the chat. So in the absence of questions, let's just continue. We have the modified account, which is the next thing we're going to basically be working on. And I think this was a lot of boilerplate codes. Oh, because okay, let's just start from somewhere. All right, so what the modified account does, right, is with the modified account, we're basically just extending the default component contract. We're extending that and we're adding some new features to it. So as you can see, for the trait of the modified contract, we just have two major functions in here. The upgrade function. So like I explained earlier when we went through like the default contracts, right? It's basically not by default upgradable. So we want to extend our own contracts and want to make it upgradable one. So we want to add this version function, which is basically going to track the version of our contracts. So every single time we upgrade our contracts, the version is going to read version 1, next version 2, and so on and so forth. There's a question. So what are the instances? Mubarak is asking what are the instances where you need to interact with the factory contract. So in this case, I assume the registry contract. So a good example of when you'd probably want to interact with the registry contract, right? Is let's say you're building okay, for example, let's just take the cast project we're working on as a good example, right? So we're building cast, which is basically like an improved version of Lens on Starknet. And with cast, every profile on cast is a Tokenbound account. Now, what we basically do, if you check the profile component within cast, right, what we do basically is every single time we try to create a profile, the first thing we do is we mint what we call the cast NFT to you. So we mint the cast NFT to you, and afterwards we try to deploy the Tokenbound account to you. Now, in this particular case, right, how would you want to deploy? How would you deploy that Tokenbound account if you do not interact with the registry? Since basically the registry is responsible for deploying the Tokenbound accounts, right? So what we do basically is we make a call to the registry, which is the factory contract in this case, right? Make a call to the registry calling the create account method. We pass in like the implementation hash and every other thing it needs, right? And it deploys a Tokenbound account for that particular profile using that NFT that has been minted for that user. Now, the NFT that was minted is minted to the user's account. So it means that the user can control his cast profile using that, and in as much as that NFT remains in his account. I don't know if that answers the question, Bragg.
Yes, it did. Thank you.
Yeah. All right. So moving on, right? As I was saying, we have the account component, right, which you can see in the core contract. So we went through that earlier. Now, what we want to do now is I want to extend our contract and add some new features. In this case, the upgrade function and the version function. So there are some things here I had to do beforehand, assuming that none of us, it's not an introduction to Cairo class. So but I'm still going to walk through it. I'm still going to try to explain it so that we can all follow along. So we start with using this attribute, right? Declaring that okay, this module is a Starknet contract, and this account you can see in parentheses here is like should I say special declaration you add to the attribute, right? To tell the compiler that okay, what's contained within here is an account component. So if this is not here, right, you see that when we try to my what's it called, my scab language server is not really working properly. But if it was working, if it was currently working right, you would see that it will throw you one in here that says validate blah 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 is like a special function for account, something like that, right? So that's just basically what we do with these accounts. We basically tell the compiler that okay, what you're seeing here is like an account contract. Then, as you can see, we import some certain things from Starknet. We're importing the syscore result rates from the token-bound accounts. Now, you would see why we now had to do this, right? Within like this particular within our Skype terminal. What we had to when we added this dependency, right? So we can have access to like everything contained within this dependency. Now, if you check the the modified account of Cairo, right, you can see that we now use that dependency to get the account component straight and every other thing we're going to be using like within this function, right? So we also get the interface and every other thing. All right, so we also get like the contract address, the class hash, the get call address from Starknet. From accounts, we also inherit the account components. Then we're trying to use this I modified account trait. So we do that using the super basically. All right. So the next thing we had to do was we had to specify our component parts, storage and account. So this is like a must for components. I think it creates the has components trait, which is usually necessary for every contract trying to like inherit a component or use a component. And so for the part of course is the account component. The storage is this account. So as you can see, we use the sub storage to like embed this into our storage. Then we also had to embed the events to ensure that all events are emitted, right? Then in here we add the implementation the account implementation basically to our contracts. So just with this simple line of code here, this is going to inherit every single function we had in our, what's it called, in our account components. That's the official reference account components, right? And this is basically what we use to tell the compiler, okay, this is an external contract and you should generate an API for it. So most of all these things are actually very simple, but if you are confused, you can ask questions or you can make a reference to like the Cairo book. And yeah, so but feel free to ask any questions you have. I just had to do this beforehand, so we would finish on time. It's already 5:53, and like I said, I want us to take questions before we go. All right, so within the okay, I've already explained this. All right, so within here, we're going to be implementing our own version of the modified account. So, like I said, just adding this alone, this here you see inherits. Let me show you that again. So I'll stop sharing this for a minute. I'll go into a minute. Okay, I'll go back into my yeah. All right, so that single line of code you saw there is going to inherit all this. So in the account component, you can see every single thing we have here, all the functions, the errors, every single thing. It's going to inherit it because of that line of code we added. Every single thing in here. So everything we see in here is already inside our contract. Now, what we want to do now is we're saying what we have here is not enough. I want to add more. So as you can see, we don't have a function to upgrade, but we want our, let's say for our own use case now, for whatever we're building, right? We want users to be able to upgrade their token-bound accounts. And now we want to add a function to do that, right? And we also want them to track the version of the upgrade. So let's say they upgrade to another version. I want to say, okay, you just upgraded to V1, you upgrade again, okay, you just upgrade to V2 and so on and so forth. So we want users to be able to do this. And we're going to be adding new functions that will enable them to do this. All right, so I'm just going to stop sharing and I'm going to start again. Yeah. And like always, if you have any questions, please feel free to ask. All right, so now within our implementation, our modified account implementation, the first thing we want to do though is all right, sorry about that, but let's go back again. So I'll stop sharing. I'll start again. Sorry for the friction. Okay, within here, let's go in here. Now, if you check this function, right, you will see we have something called the initializer. Where is it? Yeah, we have the initializer function. This. So the initializer function basically is supposed to be responsible for initializing like a new tokenbound account. So within, like I explained, right, components cannot be deployed. So we usually use an initializer within components to do what a constructor would do, right? So with the initialize, what the initializer does basically is it checks that the owner is not a zero account, then it basically writes all these things to storage, right? And then emits that an account was created. It emits the account created events, right? So it means that we need to, in order for us to deploy this tokenbound account, we need to like call this initializer function. So I'm going to stop sharing and share the other screen again. Okay. All right, so sharing the screen again. Now, it means that we have to have a constructor that would initialize that tokenbound account, basically initialize all those storage variables. So we're going to come above here just after the event, right? And we're going to add our constructor. Now, for us, this is okay. So we're going to add our constructor. So this is supposed to be a contract, basically. So it can have a constructor. And you can see function constructor. And constructor is going to basically take a reference to still, since it's going to be mutating states. It's going to take it's supposed to take the NFC contract address, right? Just going to be called a contract address or contract address type. And it's going to take the NFC token ID, which is going to be of type here in 256. Once it does this, so we're going to say self.account. Now, you check the storage variable, right? We inherited the storage, which means we have access to like the contract state and everything contained within that account component. So we're going to, well, that means, like I said, my scab language server is bad, so we have to do everything manually. So we're going to call the initializer function, and we're going to pass through it the contract address. Let me confirm that. I think that's what it takes, the NFT contract address and yeah, and the token ID. So we're going to pass the NFT contract address. And we're going to pass, let me see. We're going to pass the NFT token ID. Yep. That's as much as we need to do within our constructor. So once we do that, with that alone, right, we have our account initialized. Now what we want to do now is implement our upgraded account, basically like the new functions we wanted to add to our existing account implementation. I can't see, is there a question in the chat? Okay, can you come back on the component initialization explanation? Okay. All right. So like I said, components are like Lego blocks. They are like they help you basically inherit the code someone else has written, right? And basically work with that. So that's what we're just trying to do. The accounts, the Tokenbound accounts, right, on Starknet are components. So it means you can basically just inherit them and basically extend them, add new functions to them. And what we're doing here is if you check the Cairo book, you can see that the first thing you need to do is you need to specify this component macro, which takes in the paths to your components, takes in the storage, like the component storage, right? And the events, the component events. All right. And behind the scenes, what this components macro does, I think, is it generates the house components trees, which is necessary for like every contract looking to like implement a component, right? Then in here, what we do is we add the implementation block. So this account implementation contains every single function we need from this account contract. And what we just do basically is if you let's say take this off, right? What's going to happen is this would exist within your contracts, no doubt, but your compiler is not going to generate an ABI for this, right? So it means that this will not be visible to the outside world. So the reason why we add this is to let the compiler know, okay, I want this to be visible to the outside world, right? This should everybody should be able to see this and interact with this. It's not private. And so the compiler will generate an ABI for this. I don't know if that answers your question. So every other thing, right? The sub storage is used to mark like when you're basically implementing account storage, you have to like specify it as a sub storage. Then the events basically you have the account event which you are specifying, which is basically the events enum within the account component. The storage is the storage struct within the account component. I don't know if this answers your question. Who asked again? Temi. Temi, does this answer your question?
Yeah, no, I was asking the question in respect to when you were talking about how you have to initialize it with state, something like that.
Sorry, come again. How I have to initialize what is state?
You were explaining that since it's not deployed, that when you initialize the component, like if you scroll down, yeah, that where you did the self.accounts.initializer, you were saying that yeah,
Okay.
that's what I meant. Is that area that was looking at?
All right. So what I was basically explaining is an out account, a component, right, in itself cannot have a constructor since it cannot be deployed. So a component has to be inherited, was built to be inherited in a contract, was built to be used in a contract. And so that's the reason why we cannot have a constructor within a component. So everything you want to do within a constructor, you have to do it within what we call an initializer function. Now, this initializer function is responsible for, let's say, most times we use a constructor because we want to initialize some certain states on deployment. E.g., you're trying to, let's say, initialize in our case, right? You want to add the contract address and the token ID of the NFT that owns that Tokenbound account to the contract state, right? And so you would do that using an initializer function. Now, what's going to happen is the contract that is going to, should I say, implement or inherit this account component can basically just call the initializer function within its own constructor and pass in those details. So in our constructor on deployment, we're going to call initializer, which is going to take in this parameters and basically like initialize it on deployment. I don't know. Does that make sense?
Okay, so the initializer is what is already declared on the account contract. So you're just calling it and passing, I guess.
Yeah, so is already specified within the account component. We're just making a call to it so that on deployment is going to initialize those state variables.
Understood. Thank you.
Yeah, you're welcome. All right. So the next thing we're going to do, right, is within our modified account implementation, we want to basically write the implementation for these two functions, the upgrade and the version. Now means call the upgrade function. Now the upgrade function, what's it going to take? It's going to take the contract state. Okay. And it's going to take the new class hash that you want to upgrade to. All right. And let's just say this is going to have a class hash type so without to start doing any unnecessary conversion. All right. So now for us to upgrade this contract, right, we want to ensure that the person trying to call the upgrade is the owner of the Tokenbound account. We don't just want anybody calling like this upgrade function. And remember when I talked about the different functions within like the account components contract, I said we have the is valid signer, which is basically responsible for checking or for what's it called for checking that a caller, right, is the same as the person who owns the Tokenbound account. So or owns that NFT that owns that Tokenbound account, right? So what we're going to do is we're going to get the caller. I'm going to say let caller be equal to get caller address. That's me and mistakes. I don't know what was wrong, man. All right. Get caller address, right? And we're going to now say we're going to assert that self dot let's just make a call to the internal implementation. Self dot is valid signer, passing in the caller is returning true. So when you don't write any you don't write any comparison or anything, right? We're just saying that once this our left-hand side to return true. Else we're going to throw an error. We're going to say unauthorized caller. So that's what we're going to say. That the caller is unauthorized. All right. So we're just checking that this guy here is a valid signer. You're not a valid signer, then we're going to throw error. You can't upgrade this contract. Another thing too we want to do is we don't want our user, right, the person who owns the Tokenbound account to swap the class hash or upgrade the contract during the period where the account is locked. So what we're going to do is we're going to check the lock status. So it basically returns the lock status and time remaining. So for time remaining, we're just going to use an underscore to indicate we don't need that. And we're going to make a call to self.account dot let's just once again use this. All right, so we're going to get the lock status, and we're going to just assert that it's not locked, basically. I want to assert that it's not true. If it's true, we're going to say account is locked. So you can't do anything because the account is locked. All right. Then if all these things, all these conditions are satisfied, right? You can just simply now make a call to under the replace class syscall. We can find that in I think that's syscalls. Then we're going to the replace class syscall. And the replace class syscall, what the replace class syscall basically takes in is the new class hash you want to upgrade to. So we're going to say new class hash, and we're going to unwrap this. Let's going to finish syscall trade. So let's unwrap this. All right, so once we do that, the last thing we're probably going to do, right, is to update this. So remember, we're tracking the version, right? So once we update the version, once say self.version dot write is equal to self.version to read, then I'm going to add one to it. And with that, we should have an upgrade function that works, right? So this should give us an upgrade function that works. The next thing we're going to work on is going to be the, what's it called? There seems like there's a question in the chat. Why the underscore? Is that attribute necessary? So the underscore is basically used to like used to tell the compiler, okay, this I don't need it, because most times when if you have an unused variable, the compiler will shout at you, tell you, it's going to be a 1, it's not going to be an error, but it's going to tell you that you have an unused variable, right? So why just have an unused variable, a variable you're not going to use? So we're just using the underscore to tell the compiler that, okay, whatever variable is here, we don't need it. I don't know, Kakuza, does that answer your question? Hello, hi there. Okay, yeah. So let's proceed. We're running out of time, 20 minutes more. Yeah, so the next function we're going to want to work on is version, which is it's just basically a simple read function. So the view function just and it's going to return a UH. And all we're going to do is basically self.version read. All right, so anytime we call it, it's going to return the existing version of your contracts. So that's a simple, this is an account contract that basically just inherits the accounts, basically extends the existing reference accounts. So let's try to compile this and see if it works right. All right, so that works. That's those. Chill. I think we. Oh, yeah, because it's weird. It is weird not having this shout at me. Well, let's try again. We might not shout too. Oh well, it did shout. Let's see. So it says method is valid signer, could not be called on type, workshop, show candidates to not trace what sample, show the type mismatch. All right, so I'm missing something. Oh, okay. Unused variable. I should be able to call this. Okay, unused variable. What do you mean it's unused? Oh, okay. This was called and oh right, I can find where. So this was the issue. I remember we're making a call to the account. That was it called? The account component. So we're supposed to call this. So this should work. Let's see. Let's try again. Yep. So that works. That works. So something else we can probably do is should we deploy this or should we okay, let's just interact with the one I deployed earlier. This is actually not correct. This is supposed to be addresses, so is that right here? Yep, that's correct way of addresses. All right, so I deployed some earlier, the factory contracts, the modified accounts. Let's just play around with that. So I would take enough time to take questions. So this is the factory contracts. Let's just check that. Let me share the screen. All right, so this all right, so now let's just use let me just use Starknet. Tried to deploy this on mainnet earlier because I don't know for some reason Sepoli I was misbehaving today. Think there was like a lot of transactions in the backlog. Well, so going to read the right contracts, as you can see, this is the factory contract. He has the get accounts and he has like the create accounts. So we're just going to connect our wallets. Let's hurry connect our wallets. Yeah. And when we try to create accounts, we need to pass in an NFT contract address. So I'm going to get an NFT I own and get the details. Let me find one. Okay. So this is an NFT I own. I'm going to just copy the address and I'm going to paste that here. And I'm going to copy the token ID. And I'm going to paste that here. And for the implementation hash, this is the hash of the one I declared earlier. So let's just use that too. We're going to pass that in as the implementation hash. So what I'm just going to say 10. And let's try to write to that. All right. So that calls create account method, which is going to deploy an account. So this is the transaction. And probably will wait a while and the account will be deployed. And yeah, so we can probably play around with that later when it's deployed. I don't know, do we have any questions? Any questions at all? Not just related to this class, but other classes you've attended, things you've studied upon, what you're building, anything at all. We have like 15 minutes. Let's try to like tackle that. Any questions? Yeah, sir, I can't hear you. Can you speak up?
Can you hear me?
Yeah, I can hear you now.
Can you hear me now?
Yeah, I can hear you now. I can hear you. Hello, Mubarak, are you there? I can hear you.
Can you hear me now?
Yeah, I can hear you. I can hear you.
Okay, so I wanted to ask a question, right? If a user locked his TBA, right, can he transfer it to another account?
If a user logs his TBA, can he transfer it to another account? Yes, he can.
Yeah.
Remember the account is tied to the NFT, and what is basically transferred is the NFT, not the Tokenbound account. So while the account in itself is locked, the NFT can be moved from one person to another. And so the next user who receives the NFT can basically unlock it. Does that make sense?
Okay, so that means the next user that received the NFT, the moment the lock time expired, you have access to the TBA account.
Exactly.
Awesome. Awesome. Thank you.
I have a question. How would it be if you want to tie a TB to a person's number? Do you have to scrap an up chain or yeah?
Sorry, I don't get you.
In a
Can you?
sense of like for example, if a person with a feature phone wants to sell NFTs in their TBA, but yeah, is
I don't know if it's your network, but I'm struggling to hear you. Can you maybe type your question instead?
there
Yeah, Kakuze, you're breaking.
any method to map? So yeah, am I audible now?
Yeah, sorry, I had to mute you. There was now a lot of background noise. Just you can just type your question in the chat and I'll just respond to it. All right, guys. Any more questions? Any more questions? I'm waiting for the account to get deployed and we can just play around with it when it's deployed. So while we wait, any questions? Okay, so is there a function for one to map a TBA account to a phone number? Well, that's an interesting use case. It depends on what you're trying to build, but yeah, it doesn't from our end, it doesn't really exist. So we just provide you with like a very minimal implementation you can use. So you can decide what you want to implement. So that's up to you to decide to extend and probably do that. So just like Temi said, it's implementation specific. So that's up to you. Yeah. All right. So in the absence of questions, one more thing I wanted to highlight, right, is you have access to this contract has been deployed. So let's just play around with it before I see what I want to see. So if you go to the read or write contract section, so as you can see, we have like two new functions here. We have the version function which we added, and we have the upgrade function which we added, and the rest of the functions, as you can see here, just comes from like what's it called? It comes from the Tokenbound account we extended. So if you call the function at this point, it should be 0, right? So well, we can try to upgrade. Let's try to upgrade our contract, right? Let me see. So I'm going to take it. I want to take our contracts back to the original implementation hash. So I'm going to let's go back to the TBA core repo. Yeah, and yeah. Uh, so let's use the original class hash. I'm going to copy this and I'm going to go back to my contract and I'm going to try to upgrade this class hash. Now let's try that. Oh, sorry, I forgot to call in my wallet. All right, so let's try that now. All right, so I'm just going to confirm this on my Argent wallet, and yeah, the transaction has gone through. So when it is upgraded, when the account has been upgraded, you would see that this upgrade functionality should disappear, and the read function and the version functionality should disappear. So let's see where the status of that transaction. It's currently unreceived. So when it gets accepted on L2, we can check again. All right. So what I want, okay, it's now accepted on L2. So let's go back to check that. So as you can see, the version, it's not yet taken out. So it should be taken out though.
Sorry, that the Cisco call you wrote in the code earlier, is that what is needed to update the contract in Starknet?
Yeah, I'm Starknet. Like upgrading a contract is very simple. You're just simply swapping the class hash. So unlike Starknet, unlike Ethereum on Starknet, like the contract is already like differentiated from the code, basically using contract and class hash. So the contract is stateful and the class hash just contains the code, right? So if you want to switch or swap like the implementation, you just simply swash the class hash and we basically should change like the implementation. Um, I don't know why
Sorry,
this.
what happened? What happens to the previous states if maybe your the new implementation does not contain maybe some particular storage variables? Do they just disappear?
Sorry, I didn't get you. Come again. You said what?
If we swap with contracts like that, what happened to the how do I put it? Should I say what happens to the previous?
The storage.
No, yes, like
Yeah, so basically swapping the class hash, you're basically just swapping the code underneath. We don't tamper with the storage. So the storage is preserved, but like the what's it called? The class hash or the code underneath is swapped. So you can basically add new functionalities or take away functionalities, but the storage remains the same. I don't know if that's what you're trying to ask.
so. If there's a forgive me, if there's a storage variable in the previous implementation and this new implementation does not contain that storage variable, so that's just is that old storage variable is just lost in the void or what?
Yeah, so that's where things get tricky. You do not have as you. I don't think you have access to the storage variable. So you can add storage variable, but it's not really wise to take them out. All right, so probably there's some errors with this. I didn't bother to try this out earlier. Probably check it out later. But what I wanted to say, right, is if we go to where is that? The Tokenbound distribute. Yeah, so the working document, right? If you go under mentorship, right, you see we have like about 5 mentors here. You can definitely reach out to anyone. The link to their calendars are there. So whilst this is like the last workshop, it's not really like it's not like it doesn't mean you don't really have access to like any mentor anymore. So you could just always go over to the working documents, get their calendly and book a call and they would attend to you. So if you have any questions at all, you can either use the group chat or if it's deeper than just texts, you can just book a call. And I would say that's just about it. I think that wraps up um the series of the Tokenbound workshop. And yeah, thanks so much guys for coming around. Just one last time, is there any questions before we go? All right, so in the absence of questions, we'll call it a day then. Thank you so much, guys, and do an awesome night ahead.
Will you be pushing your code to
Yeah, I already put it earlier. I'll send the link or I'll send the link on the group chat later. All right, guys. Thank you so much for coming around. And the recording will be available later in the evening. Do have an amazing night ahead. Thank you.